students. In this class we are going to learn few new topics, students. So I think you have completed learning what all topics we have covered in the last classes. Okay. So this topic, the topic which we are going to learn in this class is take a fresh new page or continue after the previous topic, students. Put the side heading Schrodinger wave equation for hydrogen atom. Most frequently this question is asked as a short answer question, students. Okay, so this is only a 2 marks question, like you will be asked write the Schrodinger wave equation for hydrogen atom. Okay, so you should learn this equation carefully. You should practice it 4-5 times. Then you can easily write this equation. Here, students, we are not going to learn how this equation is being derived. There is no derivation of this equation in your current syllabus. Okay, so that's why we learn only the equation. Okay. So clear? So put the side heading Schrodinger wave equation for hydrogen atom. Underline the side heading also. Okay? So what is this Schrodinger wave equation? So before looking at that equation, students, first write down, we know that dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equal to 0. So what is this equation called as, students? Do you remember? Yes, this is Schrodinger wave equation for a particle which is moving along a xyz axis, that is 3-dimensional. Okay, so this we have derived in the last class. Okay, students. So this is Schrodinger wave equation. So we know this equation. So what is E and what is V, students? V is potential energy, E is total energy. Okay. But here Schrodinger wave equation for hydrogen atom. So for a hydrogen or for an electron in hydrogen atom, potential energy is given by minus E square by R. Okay. So below this equation mention or write potential energy of an electron. Potential energy. PE means, students, potential energy of an electron. Potential energy of an electron in hydrogen atom is given by V, capital V equals to minus E square by R. Okay, so let us substitute this V value in this equation. Okay, write down below. Substituting V value in the above equation. Substituting V value in the above equation, we get dou square psi by dou x square. Everything right, students, till here. Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into E minus V. Instead of minus V, you will be writing E square by R, minus V na, but V is minus E square by R. So minus into minus, what happens? Plus. So E plus E square by R into psi is equal to 0. Okay. So we have taken Schrodinger wave equation and mentioned V is equal to minus E square by R. Substituted V value in this equation. Okay. So now, students, in this equation we have used rectangular coordinates, that is x, y, z. So generally x, y, z are used in rectangular coordinate system. We know na x, y, z axis. Okay. So write down below x, y, z are used in rectangular coordinate system, as they are rectangular coordinates. Okay. But students, here we are studying about hydrogen atom. So hydrogen atom, we see that it is approximately spherical in shape. So now XYZ cannot be used as they are rectangular coordinates. Okay, XYZ axis, you know now students. Okay, so for a spherical atom we cannot use XYZ. Then what are to be used? Yes, for as it is spherical, we need to use spherical coordinates. So spherical coordinate system is to be followed for hydrogen atom. So write down students here, X, Y, Z are used in rectangular coordinate system, but hydrogen atom is approximately spherical, but hydrogen atom is approximately spherical, and hence spherical coordinates can be used. Spherical coordinates can be used. What are the spherical coordinates, students? Rectangular coordinates are x, y, z. So in the brackets you can mention r, theta and phi. Okay, as hydrogen atom is approximately spherical, and hence spherical coordinates can be used. In the brackets mention it as r, comma, theta, comma, phi, where r, theta, phi are called as spherical coordinates. Okay. So understood students? Till here r, theta, phi, what are they? They are called as spherical coordinates. So therefore Schrodinger wave equation for hydrogen atom is so students, look here, this whole thing is Schrodinger wave equation. Okay, so as this is very small, I have split like this. I did not split, I have just written the equation according to my convenience. Okay, in your notebooks you can continue after this plus. So write down Schrodinger wave equation for hydrogen atom is 1 by r square. Is it clear students, this equation for you? Okay. So 1 by r square into dou by dou r into square brackets r square dou psi you know na students, wave function. Okay, so psi of r theta phi. So instead of x, y, z we are using r theta phi, which are nothing but spherical coordinates. Okay students, 1 by r square into dou by dou r into r square into dou psi. Psi of r theta phi, close it, plus 1 by r square sin theta, 1 by r square sin theta into dou by dou theta, into sin theta into dou psi of r theta phi by dou theta, close the brackets, plus 1 by r square sin square theta, 1 by r square sin square theta into dou square psi into psi of r theta phi, close the brackets, by dou phi square plus 8 pi square m by h square into capital E plus E square by R into psi of R theta phi equals to 0. Okay. So now put this whole thing in a box. Now this equation, students, we call it as Schrodinger wave equation for hydrogen atom. Okay students, below that write down the solution of this equation. This equation means what? Schrodinger wave equation for hydrogen atom, which you have enclosed in a box. Okay, that big equation. So it has, we can solve that equation when psi is written in the form. Psi means what? Wave function. So write down that only, students. The solution of this equation is possible only when psi can be written in the form. Below write down psi of R theta phi. So you remember what R theta phi are? Spherical coordinates, right? Psi of R theta phi. So when psi along R theta phi can be written as capital R of small r. Students, small r, put it in brackets. Capital theta, this is called as capital theta of small theta. Phi, capital phi of small phi. Okay, now we will see what are these R of r, the theta of theta, phi of phi. Written till here, okay. So the Schrodinger wave equation can be solved only when psi is written like this. Okay, so we are not going to look into that equation, which is very, very complicated. In the textbook itself, you will find that equation split into 3 parts. Okay, so as of now, we don't require that solution. Okay, students. Fine. Okay. Now, R of R is called as function. You know, students, in mathematics there will be various functions. So like that, this R of R is called as function depending on R. Function depending on R and independent of theta and phi. Okay, and come on, capital theta of small theta is the function depending on theta but independent of R and phi. But independent of R and phi. And phi of phi is the function depending on phi but independent of R and theta. Okay students, these are 3 functions which are depending on their respective coordinates. Okay, full stop. But independent of R and theta. Okay, below write down, don't continue, below. The function R of R is called as radial wave function. Mention it as radial wave function. Underline it students. And the product of capital theta of theta and capital phi of small phi is called as angular wave function. Okay. So when you are asked what is radial wave function for as a 1 mark question, write down Schrodinger wave equation for hydrogen atom and write down this sentence and write down function R of R is called as radial wave function and product of capital theta of theta and capital phi of phi, we call it as angular wave function. Okay students, so there is no derivation for this, just you should practice the equation, which is a very big and also a very, very important question. So draw a line till here. Till here is your answer for Schrodinger wave equation for hydrogen atom. Next topic, put the side heading, probability density. This is also a short answer question students. So probability density. So, when do we use this word probability, students? When we do not know the correct information. Okay? So, as we all know, with the knowledge we are having, that electron, we cannot assign specific position to the electron of particular energy at a given moment. Right? So, but there is a possibility of finding probability of the position of that electron. Okay. So, therefore, when we do not know the correct position or the correct information, we use the word probability. Okay. So, how to explain this probability density? For this, we need to consider the electromagnetic radiation which has dual nature. So, write down, students, put the side heading probability density and write down the first sentence as, let us consider the dual nature of electromagnetic radiation. Let us consider the dual nature of electromagnetic radiation. So, there are two theories to explain this electromagnetic radiation, students. Wave theory and photon theory. So, what are these two theories explaining about this dual nature of electromagnetic radiation? Okay. So, first point, according to wave theory. Write down, according to wave theory. That means wave theory explains that the intensity of radiation can be measured using square of amplitude of wave. We know amplitude of wave. With which letter or which letter represents this amplitude of wave, students? Do you remember? Yes, psi, that is a wave function which represents amplitude of a wave. Generally, psi has no physical significance, but psi square has some significance, students. Okay. Therefore, now this psi square tells us the intensity of radiation. This is according to which theory? Wave theory, right? So, the first point, the second point, according to wave theory, the intensity of radiation is measured by square of amplitude of wave. In the brackets, mention it as psi square. Psi square. Okay. Next theory. According to photon theory. Next point, students, below write down. According to photon theory, intensity of radiation is given by. Here, intensity of radiation is given by psi square. But photon theory says that intensity of radiation is given by the number of photons present in a given volume, which is called as photon density. Okay. Given by number of photons present in given volume, that is photon density. Students, but these photons are of very, very small size. How to count the number of photons present in a particular volume? It is not possible. But there is a possibility. What is that possibility? We can find or predict the probability of their existence in the given volume, which is called as probability density. Okay. So, since photons are small particles, photon density is given by probability of their existence in a given volume, which is called as probability density. So, from the two theories, what do we understand, students? First theory, intensity of radiation is given by psi square, that is square of amplitude of wave. Next, photon theory, intensity of radiation is given by probability density. Okay. Now, combining these two theories, probability of finding a photon in a given volume can be related to psi square. Okay. Probability of finding a photon in a given volume is nothing but probability density. So, combining these two theories, we can come to this conclusion that probability density is related to psi square. Okay. So now below write down. Therefore, chi-square is the measure of finding probability of finding an electron in a given volume. Okay. Chi-square is the measure of probability of finding an electron in a given volume. Below write down. If the probability of finding an electron, this is the basis, students, okay? So with this base we can conclude that chi-square. We can use this chi-square to know the probability of finding an electron in a given volume at a particular moment. Okay. So if the probability of finding an electron which is moving along 3 axes, if the probability of finding an electron moving along 3 axes, or you can mention it as moving in 3-dimensional axis, that is x, y, z, is taken as P of x, y, z. Try to understand this sentence, ma. If the probability of finding an electron moving along 3 axes is taken as, this is P, not a row, okay? P of x, y, z. P means what? Probability density of the electron which is moving along x, y, z axis. So how did we mention here? P of x, y, z. Then this probability of finding the electron moving along 3 axes is proportional to chi-square of x, y, z. Okay. So this is the way we can find the probability density of an electron which is 3-dimensional. So draw a line till here, students. This is the answer for probability density. So students, the topics we have learned in this class, what are they? Forgot? No. I am there, okay, to remind you. Schrodinger wave equation for hydrogen atom and the probability density. Both are short answer questions only, students. So both are easy. They are easy for me. They are easy for you also. Okay. So practice that Schrodinger wave equation, ma, and this probability density. Learn this topic also. Okay. So I am closing. These are the topics for this class. I will continue in the next class with a new topic. Okay, students. Take care. Stay safe. Bye-bye.